People have been monitoring the rise of the oceans using a variety of different techniques really since the late 1800s. We have records from tide gauges. These are single point measurements of the rise of the oceans in a few places scattered around the world. But over that time, we've seen that human beings have caused about 20 centimeters of global sea level rise since the Industrial Revolution. That's a number that's really quite staggering. However, since the early 1990s, we've been measuring sea levels from satellite altimeters. These are satellites that tell us the height of the ocean and give us a global view of human-caused sea level rise. So now we're able to measure global sea level rise with an accuracy of just a few millimeters from space. This has revolutionized our understanding of human-caused climate change because the rising oceans are one of the most important indicators we have of our planet's warming. Sea levels change across the planet for a variety of reasons. Tides, currents, the movement of heat throughout the ocean, all of these things contribute to sea levels changing locally. But when you average over the entire planet, you begin to see a bigger signal, one that has the footprint of human-caused climate change. Averaging over the entire oceans allows us to see the increase in volume of the oceans. This happens because heat is being added to the water, but also more water is being added from melting glaciers and ice sheets. The two of these things together make an incredibly important indicator of humankind's footprint on the planet's climate. In addition to measuring sea level with satellites and tide gauges, there are also records of sea level that actually go back thousands of years based on proxy records. People in places like North Carolina are able to dig down into the sediments just at the edge of the ocean and reconstruct a record of sea level rise that goes back over 2,000 years. During that time, sea levels across the planet were incredibly stable. We were living in a warm climate, it wasn't changing very much, and global sea level rise did not change either. Then in the late 1800s, sea level rise began in earnest. This was the beginning of the Industrial Revolution, the beginning of human-caused climate change on the planet, and the beginning of our incredibly rapid rise in global sea levels. This rise is one of our most important indicators that we are affecting the entire planet. If you think about it for a second, over 2/3 of the planet are covered by oceans. So if those waters are rising, it means we're literally reshaping 2/3 of the planet's surface. That's a really big signal, and the only good explanation we have for it is human-caused climate change. We've used a series of satellites to measure the changing oceans from space. These began with Topex Poseidon in 1992, followed by Jason 1, Jason 2, and just this past January, Jason 3. We have all sorts of tools for measuring sea level rise and what causes it. One of the really exciting satellites we have is called the GRACE satellites. This pair actually circles the Earth with one chasing the other. The two satellites are nicknamed Tom and Jerry, and whenever one goes over something heavy, it speeds up just a little bit due to the pull of gravity. The second one follows sometime later, and by measuring the distance between the two satellites, we can calculate the weight of the thing that they were flying over. So, in the instance of something like Greenland, this pair of satellites allows us to measure the changing mass of the Greenland ice sheet. As ice is lost from Greenland, it runs off into the oceans, driving sea levels higher, and this signal is clearly measured in the GRACE satellites. One of the most important discoveries of the GRACE satellites was the net loss of ice in Antarctica. Some regions of Antarctica actually have increasing snow levels, but these are far outweighed by the loss of ice around the edges of the continent. It wasn't until the GRACE mission flew that we were really able to say for certain that as a whole, Antarctica is losing ice and contributing to sea level rise. Of course, the rates of sea level rise are changing very rapidly as well. Looking into the future, we expect sea level rise to double or even triple in rate over the coming century. We could be looking at somewhere between 1 and 2 meters of extra sea levels added to the oceans by the end of the 21st century. But which one is it going to be? The difference has huge implications for coastal cities across the planet. This means that one of the most important questions in studying sea level rise today is how fast is it going to happen in the coming decades? To answer that, we have a variety of tools. JASON 3 will soon be followed by JASON CS. This is a mission led by the European Space Agency, but with NASA, NOAA, EUMETSAT, and CNES as partners. It will extend the sea level record from 2020 to 2030, adding another decade of sea level observations to our, by then, 30-year-long record. Another exciting development that's just around the corner in satellite altimetry is the upcoming SWOT mission. SWOT stands for Surface Water and Ocean Topography. This will be a very high-resolution version of our existing altimeters that gives us a really close look at how small-scale things in the oceans are changing, and also how water in lakes and rivers all across the planet is changing. As the planet heats up, ice around the world is melting. This is true of sea ice in the Arctic, small glaciers and mountains across the world, as well as the huge ice sheets in Greenland and Antarctica. The last of these are causing sea levels to rise already very quickly. Scientists around the planet use data from a variety of satellites, like the GRACE missions, CryoSat, the upcoming mission IceSat, and also airborne missions, like the new NASA mission Oceans Melting Greenland, or OMG for short. OMG is a 5-year NASA mission with airplanes to try and measure the extent to which the oceans are eating away at the Greenland ice sheet from the edges. Warm water from the oceans actually comes in direct contact with many of the glaciers that carry ice off of the Greenland ice sheet into the sea. As this water warms, it can melt the glaciers, causing them to speed up and accelerate the rate of ice loss and the rate of global sea level rise. OMG hopes to answer, how fast will oceans melting Greenland happen in the future? The GRACE mission measures the amount of ice lost from places like Greenland and Antarctica, but it also weighs the ocean. By weighing the mass of the ocean, we can see just how much water is being added every year. About 2/3 of modern-day sea level rise is driven by the addition of water to the oceans. The remaining amount is caused by the expansion of the water as it warms up because of the absorption of heat trapped by greenhouse gases. To measure the thermal expansion of the waters, a system called the Argo Array of Profiling Floats provides scientists with temperature and salinity measurements in roughly the top half or 2,000 meters of the oceans. This allows scientists to calculate the amount of thermal expansion and the contribution to sea level rise from the warming oceans themselves. In the future, the Argo Array will extend all the way to the ocean bottom, allowing scientists to measure the full volume of the changing temperatures of the oceans. This is an incredibly important climate parameter because over 90% of the heat trapped by greenhouse gases is warming the oceans. Accounting for that heat is an important part of measuring humankind's footprint on the changing climate.